The first is around green revolution in IT. I think that is one of your favorite subjects as well, and it's a constant challenge, I think, for you all, right? Ensuring green revolution within IT. And Digisol would like to bring you that subject, the topic, and share some of your concerns and also address some of your concerns today. And I would like to introduce, Mr. T. Venugopalan, National Services and Sales Head for SmartLink Networks Systems Limited. Venugopalan has about 22 years of service in the IT industry, and with the exposure to varied IT entities. And he has joined SmartLinks in 2004. And prior to that, he had been with HCL Comnet for almost 10 years, so which means he brings a lot of experience behind him. And I would really, you all would enjoy his sessions. And I would welcome Mr. Venugopalan to address the green revolution related challenges.
Good afternoon. I think you had a good lunch, so it's my challenge and ensure that we all wake up and we all have a good session for the next 45 minutes. I was told to stop at exactly 45 minutes, followed by test. So I've been keeps giving a lot of seminars, lectures and everywhere. I think I've seen a very good crowd today. I'm very happy and excited to talk about for the next 45 minutes. More than everything else, I come with the experience which I have come across. It's something unique. I'm sure everyone will agree with their own experiences, because IT is the ocean, as we all know, and everyone will not get a chance to work with all the technologies. I hope you all agree with me, right? Some people have got exposed to VPNs, some people have got exposed to MPLS, some people have got exposed to VLANs, inter-VLAN routing, some people have got exposure to policy-based routing. IT as an industry, IT as a infrastructure. Without IT, no business happens, and it's become a part and parcel of our day-to-day activities. So if I want to talk about myself, I started my career in 1990. 1990, I was working on 9.6 kbps for a Tata Electric company in Bombay. 9.6 kbps through a LAN extender. That was a big bandwidth at that point in time to communicate from point A to point B. I'm talking from 1990. Whereas from 1990, I can say that the IT started growing from slowly to the next level, because if you really want to go back to the IT as a information technology, as the way it's evolved, I think I just want to talk some 2-3 minutes about how with my experience. I think you all would have heard of a physician called Mr. Sir Arthur Clarke, right? Sir Arthur Clarke. He wrote an article somewhere in 1945. Just he wrote a one-page article saying that, he said, if you keep some object at 35,500 kilometers away from the Earth, the global communication is possible. That he wrote an article in 1945. You just imagine, you just thought how prior to 1945 there was no computers. I'm talking about around 70 years back. There was no computers, right? There was only telephone was there. There was no radar communications. There was no emails. There was no chat, there was no videos, there was no video conferencing, nothing, right? He just wrote an article saying that why I mentioned about Sir Arthur Clarke is, we just need to give an importance, we just need to give a thought process, is thinking about it, how we thought about it, how the world is going to move. Then we had Bill Gates, we had so many other people. In 1980, Bill Gates talked about himself. He said, I will ensure that each and every people on this universe will have one desktop, right? Today we just can't imagine without a desktop or a laptop. Then billions of business happens through computers, right? So I think we will have to just give an answer to all those people who thought about it. What is the vision? How things will go in the future? And if you look at the last 30 years, how we have grown, and the way things are going, under 3 years or 5 years down the line, will be much more than what we have done in the last 30 years. And things are happening. IT as a I can say, I see as a commodity. IT as an activity. Without IT, we just can't think of living without IT. And internet started flowing from 1995, 95 people thought that 32-bit addressing is more than sufficient, 2 to the power of 8, right? Now 2 to the power of 4, 32 is more than sufficient. But today IPv4 has got exhausted, and not today, more than 6-7 years back, and people came out with the concept of PAT-NAT to postpone the problem, because IPv4 addresses got exhausted so fast that we don't have. If a new company wanted to come onto the internet, they don't have address to get into the internet. That's how IPv6 came into the picture. A lot of things happened. Then VPN came into the picture. VPN came because we just wanted to use internet as a medium for communication, data communications. But when we are sending messages through internet, we had a problem. People might get hacked, information get leaked. So we came out with the concept of VPN. VPN is for using public infrastructure for private use. So many things started happening, and things started growing in a phenomenal way. And today my topic about is green revolution in IT. What is that green? I would like to talk about something about green. Why we're not talking about red? Why we're not talking about blue? But we are talking about green. There is a lot of things we can do with respect to the green as a product. So if you look at India as a country, India is always a power-hungry country, right? We all know that demand is very high and supply is very less. And even if you generate, I can ask questions, right? Okay. So that it will be a two-way communications. I don't want to be a one-way communication. Don't be a broadcast share. I would like to be a multicast share. So what is the power requirement for let's talk about India as a country. How much power we need to power on? Could be bulbs or computer servers or switches or anything. How much we generate, any guesses? I have the slides. Just one figure, some figure. Watts, milliwatts, megawatts, gigawatts, kilowatts. Okay. Any other guesses? No. I think I will put my questions properly. How much power we need, India as a country, to ensure that we power on whatever we have. Like in my house, I may have fridge, I may have AC, I may have a laptop or a computer, right? I may have a wireless access point. If I go to office. If I go to my office, I have switches. I have chassis switches. I have 5,500 people working. So I have a port for each and every access switches, then routers, all those things, servers, all those things. It requires power, right? Because my point today, my speech is about green only. So I need to talk about green means related to electricity, right? We all need power, right? Whether we have a POA switch, whether we have ordinary switch, even if it is access point, we need to power on. We need to give 230 volts power, right? Or 50 hertz frequency, right? Okay. That's it. Okay. Gigawatts. Okay, fine. It's a good question. I think I always go to two people. One is uncle and auntie. I say uncle is Google, auntie is Yahoo. If you do not know anything, I'll go to them. I'll just Google it. I'll get the answer, right? So if I say uncle, auntie, you people will laugh. At least you people are awake, right? Fine. Thanks, sir. Going to the why we talk about green, right? So this is a small slide which I picked up from Uncle Google. He says electricity sector in India had an installed capacity of 205 gigawatt as of June 2012. We are the world the consumption is a fifth, okay, after Russia, after UK, after Russia, USA and China. Then thermal power plants constitute 66% of our installed capacity. Hydroelectric about 19%. Rest being a small combination of wind, hydro and other waste and other nuclear products. But one thing which I want to talk about, let's say I generate 100 watts of power or 100 kilowatts of power. I think if I don't know how many people are from Karnataka. I have seen a lot of people from outside Karnataka. If we go back to Karnataka has got something unique when it comes to power generation, right? We have in Shivanasamudra, right? Hope how many of you have heard of Shivanasamudra? The first electricity was generated in Shivanasamudra for the entire Asia. We got the first, this is very around 100 kilometers from Bangalore, from this place. Okay, that's one thing. First in Asia. Pardon me? What's the plant name? Shivanasamudra. Shimsha, we call it a Shimsha. 1901 if I'm right. Okay, so that time I really do not know. This is not. You're the first. Okay, number one.
It doesn't have the data.
Data is not there.
Hydro, thermal, or hydro?
Hydro. It's a good hilly area. The water flows. Okay, and we have so many power hydroelectric stations in Karnataka. We have Nagiri, we have Mahatma Gandhi. In after we move from Shimoga, then we have so many plants. Then Sharavati. Hope you all have heard of Sharavati. Like if you go to Bombay, you have Tata Electric Company, right? You have BV Puri, right? Tadgaon. So many places where they get generated electricity. One is the plus the nuclear power plant. Nuclear power plant, we know there's a challenges, radiations, all those things. Second thing is when we generate electricity, whatever the watts, to be 500 watts, 50 watts. But when you do the distribution, right? Let's say the Nagiri is somewhere around 500 kilometers from this place. If I need to draw a power from Nagiri all the way to here, I need to come through the transmission wires, right? As I get the power from the transmission wire, there are a lot of losses happens. So the moment I generate 100 watts of power, for example at Nagiri, the moment it comes to Bangalore, it will be only 60 watts of power. 32% is a loss actually, because it's 100 minus 32, much 70, 68 watts. If I spoke about megawatts, only 68 megawatts only you will get for every 100. So look at the losses we have. Whereas if you go to other countries, the developed countries, there is also losses there, but the loss is around 16%. In our case, it is around 32%. Because we are not able to handle whatever the reason. Okay, that's one thing. So the way I spoke about this is, as power generating, there's a challenge in generating a power, number one. Second thing is there's a distribution, transmission. There's a huge loss in the transmission. I got an opportunity to work with KPTCL, Karnataka Power Transmission Corporation Limited, and KPCL for a project where we installed the VSATs for them for data communication and SCADA communications. That's where I got a chance to visit all these places to understand how it works. Huge dams everywhere. We store the water for generating electricity. It's a very complex process. So we at home we enjoy switching on and switching off. The power doesn't come so easily. So it goes through lot of process. Okay, lot of process. One thing. Second thing is 300 million Indian citizens had no access to electricity. Okay, this is a fact. In India, in December, still if you go to so many villages, the electricity is a major concern. And over 1/3 of India's rural populations lacked electricity. And 60% of population also lacked electricity. And what is the disadvantage with this? We get blackouts, power shedding, interrupted irrigations, and manufacturing across the country, right? So what is that we can do? So why I like to throw one more question to you. Okay, assuming I don't want to go to the exact figures, just for understanding. Assuming India requires say 100 gigawatts of power, for example, to power on the entire electrical appliances, electronic appliances. Could be servers, could be laptops, could be data centers, could be lighting, street lighting, could be surveillance, anything put together. Okay, let's say 100 is a figure which I am going to talk about. Okay, out of 100, how much of percentage is we use for our IT? IT is the servers, the IT is our switches, routers, ISPs, internets, all those things, right? How much percentage I'm just asking you? Huh? 20%. No, I think, is my question understood? Am I clear on what I was supposed to ask? What I'm telling you is, let's say we have 100 watts of power. 100 watts is what we generate for a country. Out of 100 watts, we require 100 watts of power for powering on all the items in our country. You can go to Bihar, power on the street lights in Bihar. Come to Kanyakumari, power on the street lights. Or go to your house, you go to your house, power on your AC. Or go to your office, power on your laptops, computers, servers. Go to data centers, power on. Okay, everything is to be powered on, right? Okay, in that you remove all other items. You remove the civil part of it. Civil part is where we need the motors we need for pumping water, right? So batteries, all those things remove. Just focus only on the IT, because we are all IT professionals here. We will focus only on IT. Let's take for example my company, my office. I have around 5 switches. I got 48 port switches, 5 switches. That means I got around, even if I take 50 ports, 50 into 5, 250 users are there. For 250 users, I have 250 laptops and 5 switches and 1 router right? I'm not considering AC and all. I'm not considering lighting and all. I'm considering only the IT equipment. If I need to power on only my IT equipment across the country, what is the percentage of power we need out of 100? 60%. Interesting. Doctor, I think we have one Mr. Dr. John. I think he was a doctor and he has moved. I hope we discuss, right? And I'm happy to share that he was professionally was a doctor, but he liked the IT as a field and IT as an area, so he's working in the IT technology for the last 15 years plus. Anyway, now I think I'll again explain you. I hope my question is clear, right, all of you? Right? Take this place as an example. We have a power for this lighting, power for lighting, so there's so many lights. There's only one laptop here, right? And there are power for the projector, right? This all I don't consider as an IT. I consider IT as only for the laptop, right? If I have a server's access point or cameras, consider that also an IT product. So how much of power we require out of 100 to power on? Percentage, anyway, I'll answer it. It's 68%, very close, still on the higher side. 2% is the correct figure. You can Google it, you can go to Auntie and check. Okay, 2% is the right figure. Okay, this is I've done a lot of gone through a lot of journals. Then I'm telling you this. Okay, no, 2% is what's required. Out of 2%, if you save around say 0.5% of 2%, it means hundreds and thousands of villages you'll give a power, right? And what I spoke about here, manufacturing blackouts and power shedding, interrupted irrigation and manufacturing across the country can be avoided, right? So out of again one more question. Out of 2%, there are servers, right? Because we now in the last 10 years or 15 years we talk about. Take me as an example. I send a lot of videos, a lot of photos. We have YouTube, we have Yahoo videos, so many things. We transfer huge amounts of data from point A to point B, right? And we are doing a lot of video transfer, multicast, unicast, broadcast, and we need all our servers to be on always, right? Just imagine Yahoo or Google. Okay, if I want to ask one more thing, how many servers Yahoo has and how many servers Google has across the world? Google as a company or Yahoo as a company, how many servers they have to maintain? Yahoo has got stock market content, Yahoo has got chat content, Yahoo has got mail content, right? For mail they have a separate mail servers, for chat they have separate chat servers, right? For video they have separate videos, for so many things. Similarly, Google also has, they have servers all over the globe. If I want to access some information in Bangalore, I don't want to go to yahoo.com. Yahoo.com gets converted into yahoo.co.in and just get to the local server in Bangalore. I don't need to go all the way to yahoo.com in UK and get the information from UK server, right? So if you look at Yahoo as a Yahoo or Google, Yahoo has got around 1 lakh servers, okay, and Google has got around 7 lakh servers, okay. Just imagine the lakhs of servers has to be powered on always. I'm talking about from 2%, okay. The 1 lakh includes the global servers, not pertaining to India, but India I don't have the correct figure on how many servers we have. I think we have 7,000 servers if I'm right on Yahoo. That's what I checked recently. So to talk about Indian point of view, 7,000 servers only for Yahoo to be powered on always, powered on continuously 24/7, right? They cannot switch off and switch on the servers, right? If you remove the server part of it, okay. I'm talking from the 2% point of view. From 2%, how much a percentage all the servers, it's segregated into two things. One is networking. Networking is switching, access point, IP camera, surveillance. These things are the networking, and servers, storage as other component. If I segregate server, I hope you all with me, right? Going okay, right? Look from server storage point of view and networking point of view. Networking is ports, routers, switches, right? Because if it is a 5,000 node network, you need 5,000 ports, right? Minimum 5,000 ports you need, right? So if I segregate the ports from ports as well as the servers point of view, so how much a percentage we need to take care of the networking part of it, the switches, servers, IP surveillance, how much is for the servers on 2%? And exactly, very close. 1.5% is what the servers and other products, server storage requires, and balance 0.5%. 1/4 is for the networking. Okay, in 1/4 of networking, we are just coming to the 1/4. That is how much we have come to around 0.25 or 0.5, 0.5 percentage out of 2%, right? In 0.5 percentage, what is it we can do to save electricity on the networking items? There are a lot of technologies we have innovated. I'll give an example. This one thing is, if it's still India as a country, even US as a country, a lot of countries they come out and started giving a lot of understanding on how we need to save electricity. If you go back to 15 years back or 20 years back, I don't think so anybody would have known about talk about the building. They said it's a building. They never said it's an intelligent building. Today people talk about intelligent building. You go to any architect, he never uses the word building. He uses intelligent building. Intelligent building is, it takes care of the structured cabling, takes care of the wiring, takes care of the power, the solar. Even I have seen one the new concept in Wipro office, where you don't need air condition at all. They have constructed the building in such a way that the light is all, here we export so much of light here. There is no light at all. The power is more than sufficient. During daytime, they don't as long as sun is available between morning 6 to evening 6, they don't need to use electricity at all. They're saving so much on electricity. That is from the building point of view, of the civil point of view. Coming back to the electricity from the networking point of view, as a switching port. So let's say I think we've seen a lot of enterprise customers. We've got 5,000 on network. If I give us some example of Sintel as a company, they got 25,000 employees in one location. Infosys as a company, they got 1 lakh plus employees. Lot of Philips as a company, they got so many employees, so many ports. All those people, minimum, I don't know how many IT professionals, 2 million is IT professional who are working on the IT day-to-day hands-on, day-to-day activity. 2 million people who work on IT. Out of 2 million people, how much power it can save? So that, as we discussed, India is always a power-hungry country, right? Demand is always high, supply is always low. That, if I talk about from the power point of view, from the green solution point of view, if you take from switch point of view, if you have a switches, right? The Digisol switches, any green product switches, you have a 24 port switch or 48 port switch. Okay, take for example simple 24 port switch. The 24 port switch, that switch will go to the enterprise customers, the switch will also go to the government customers, right? I'll take an example of government customer as well as enterprise customer. Government customer, if it goes, what happens? Probably after 5:30 at 6 o'clock, normally they don't work because they get a cab, they get a bus, they have to leave that place. Normally sometimes they might switch off the monitor, sometimes they leave the monitor on and go, right? Number one. Second thing is, there is no question that they will switch off the switches, because 24 port switch or 48 port switch, somebody will be working late in the evening. So if we can't afford to switch off the switch, that certain switch does not have a switch at all. So it's powered on, left it on. It works for 8 years, 9 years. What about the mean time between failure or return on investment? It works for so many years, right? So switches are work. So you take an example, government case, out of 24 port switch or 48 ports, let's say 48 port switch, 24 people are working, 24 people are not working between evening 6 to morning 9 or morning 10. So when they are not working, not straight away, I save 50% of the time or 50% of energy. Advantages, I may talk about power, green. Second advantage, what I get is, I get my life of the product shoots up. If my product is not powered on, I don't require my fan to continuously on. My fan, the cooling is not required. The cooling normally gives carbon dioxide, right? Cooling gives carbon dioxide, and that is point number one, right? So that means my mean time between failure is, let's say, it's 8 years. My mean time between, if it's a green product, the mean time between failure will become 12 years. Agreed or not? All of you with me, right? That is one thing. That is from the port point of view. And second thing is the cable end point of view. We all know electrical, right? What is the maximum distance I can go from switch port to the end user laptop? 90, correct? 90, take patch cord 3 meters here, 3 meters. Say including patch cords, I can say 100 meters. As per the Ethernet rule, as per the cabling rule, it should not exceed more than 100 meters, right? And it is not always correct that all my end users, let's say if I am the switch, okay, from my point of view, I don't think so all 24 port or 48 port will be 100 meters away from me. Some may be 100 meters, some may be 10 meters, some may be 20 meters, some may be 30 meters, right? I take care of designing in such a way that if somebody is 100 meters, close to 100 meters away, I'll pump him the maximum power required to power on the end device. Somebody is just less than 10 meters, I don't need to give 90% of the power to the 10 meters distance, right? I'll reduce the power. As the cable length increases, power goes up. As the cable length comes down, power also comes down. In that scenario also, I'm saving the power. Right? That's the second. This is the concept on the green solution. How we design our green technology products. If I live for 100 years, if I'm a green guy, if I live for 100 years, minimum I live for 140 years. With all these things green embedded into me. Right? That's how it is. So advantages, you get a mean time between failure shoots up. Then second thing is the life of the product goes up. The third thing is I am reducing my power requirement. When I reduce the power requirement, let's say I need 100 kilowatts of power UPS. With the green solutions, I don't need 100 kilowatts. I can reduce it. I can 80 kilowatts of power. Or even though I need 100 kilowatts of power, but my incoming power also comes down. I don't need 100 kilowatts of power, right? So that's why it's the advantage when we talk about. So I'm talking about from the 0.5% of the from 0.5 networking products available in the country, how much we can reduce the power with the help of a green solutions. If you look at, I'll also tell you I got good slides to talk about. So what are the advantage we get with the help of a green? What is the main advantage when we talk about green? Anybody? Why should we do it? 0.5% only. Now I can leave it, right? Why should take advantage? I'll get power saving fine, cost saving fine, carbon excellent. I'm emitting less carbon dioxide. If you go to the big data centers, I think you all have worked on good data centers. Two things you need. One is you need to power on the data center. Second thing is you spend a lot of power on cooling the data center. Agreed? The more you cool the data center, the more you emit the carbon dioxide. So you need to give fan, you need to give refrigerator, you need to give air conditioner, right? You need to give so many things to cool. Indirectly you are. And what is that you are doing it? Indirectly. See, IT as a company, IT as a commodity, or IT as a, I use the word IT as a vertical, okay? We all have IT professionals. We need to do something for the society, right? We need to save our planet, right? The global warming. I think all of you are this later. Is our my point here is we need to look at things differently. That's my point here. And what is the solution for this? What is that we can do as an IT? Any immediate guesses? Teleworking. Perfect. See, with the advent of it's right actually, with the advent of video conferencing. Okay. Earlier, and now even the aviation industry is also going in a bad shape because of IT. You can say a lot of people started not using the aircraft; they are using telework, right? Doing video conferencing. Just joking, not that related, but still. So to avoid this kind of a problem, we can talk about telework, right? This is one aspect which talks about energy is wasted. Second thing is we are doing a lot of air pollutions, water pollution, and land pollution, right? There are a lot of pollution happens because of the travel. Third thing is global warming. Just look at in 1979, according to 2003, ice cap at North Pole continues to shrink as we move from 1979 to 2003. Just this is the data which I got. You all agree with me, right? I think you all might have changed 4 or 5 times your mobile phones, or 2 or 3 times your laptops. Probably you may not be using your desktops, which you bought 10 years back, right? So what are you doing with the waste, e-waste, right? So in US alone, some 500 million obsolete computers and 130 million cell phones are thrown out every year. So some of the examples is, one is energy saving, disposal of electronic waste. Third thing is virtualization of server resources, telecommuting, end user satisfaction. So this is one thing which we can think of as a virtualization. So virtualization is around hundreds of servers gets virtualized into a one big server, so that the power requirement and power requirement for all the servers comes down drastically. Also the power required for the monitor also comes to, we don't need so many monitors, we need only one monitor to take care of the virtualized servers. This is one concept where we can think of reducing the number of servers, thereby reducing the going into the green environment. Second thing is telecommuting, teleconferencing technology. You can make use of the teleconferencing technology for video conferencing from point A to point B. And green product is, can you tell me anything about recyclable packing material? So we can also we can do the recycling of the boxes. Say if you buy an access point, if you buy a switch, if you buy 8-port switch, 16-port switch, right, you get a box, right? Even those boxes can be recycled and come back and can use the same box, so that we all these things comes from where? Tree only, right? We cut even the paper. If you take, we are cutting the tree and getting and converting the tree leaves into a paper, right? So we can make use of the recycling. We do the recycling of all items, which helps in power consumption, conservation, technology, as per the EEE standards. And there's something called smart LED solutions. I'll just explain you what is smart LED solutions. Okay, then environmentally friendly OHS components. Innovative engineering design and fanless design. When I talk about fanless design, I have a product, the switch. Okay, that's all the switches will have a fan, right? Because it has to keep on continuously on, so that the component doesn't get heated. The components gets heated, the life comes down, right? So I want the fan to turn on only when it is heated. When it is not heated, I don't want fan to turn on. If a fan to turn on, the motor has to start. I need power, electricity, right? So I don't want power, electricity to start unnecessarily. If it is already a cooled place, I don't want fan to trigger. It should be off in off conditions. Whenever the temperature goes to some level, the fan should turn on. So this kind of innovative mechanism which we can think of to reduce the efficiency redefined on this link down power savings, cable and power savings. As I told you, the cable length, as the length increases, my power requirement goes up. Same thing happens in the wireless. For example, we all know access point, right? Talk about access point. Assuming this is the access point, I have kept access point here, this is antenna. And you two people are front row, requires less power, less RF power, whereas the last row requires more RF power. I do not want to pump the same amount of RF power for everyone. If the client is nearer to the access point, pump less RF power. If the client is far away from the access point, pump more RF power. Advantage I get is I am not radiating my RF power continuously across all. And as I am playing on with RF power, my mean time between failure also shoots off, my power requirement also comes down. If we keep on have to continuously pump RF power, then my power has to be continuously on, right? So on the wireless product also we talk about the green solutions. So this is one of the slide. So link down power savings. What is that link down power savings? Okay. This is very clear. See, as I look at the end device, if the end device is powered on, okay, I will trigger the port to on. The end device is powered off during non-office hours, I will trigger the power to off conditions, thereby reducing my power requirement, which increase in my generating the revenue for myself, as well as for the product, as well as for my end customers. My end customers are my colleagues, right? And save energy, link down power saving, save energy on unused ports. When the ports are not used, save energy. Link down and timer expired. Normal link setup link pulse wake up state, signal detected, sleep time expired, and when low power state. As good as when power is not required, turn off. Power is required when the CPU has come alive, just activate that port. When CPU is not come alive, deactivate that port. This is what it means. And also with respect to cable length power savings, if the cable length between point A to point B is less, give the less power. If the cable length between point A to point B is more, increase more power. Play around with the power algorithm so that your input power is taken care. And LED. Sometimes if I am having a brightness, then I want my LED to work at 100%. Right? Sometimes if my LED is in the dark location where I can able to see the clearly, so I don't need my LED to be powered on at 100% utilizations. So I can reduce the LED. LED also consumes power. Though it's small, but it adds to it. I always have a small saying: every small drop of water adds up to, right? Hope I'm right? Every small drops of water adds up to the ocean. So everything adds up to the power savings here. This is energy efficient, saves power during periods when no data is being transmitted across link. There's one more point here. One is the powered on. Assuming the powered on, and the employee would have gone for a meeting, and would have gone out for a call. So that point in time, there was no data transfer between that CPU and the other CPUs. There's no data transfer. Just also you keep him in the sleep mode, so that the power is not wasted unnecessarily. That point is also taken care here. So energy efficient, say up to 2.2 watts per port. Just imagine if it is a 24 port or 48 port. If I can say, even if I look at around 20 ports, 20 into 2.2, around how much? 44, right? 44.44 watts of power I can save on an average. This is a huge wattage saving. So time to cool me, switch on, fan please. So I'm looking hot here, please switch on the fan. So the intelligent processes algorithm will take care of the fan to power on. There's something called innovative POI. Why do we need POI switches? We need to power on access points, we need to power on IP phones, right? Okay. This is about on the wireless solutions which I spoke about, eco wireless solutions. As the distance goes up, this is from the other vendor, this is from the Digisol solutions. As we are near, this is the power actually. As we are nearer to the client, send less power. As we are farther from, this is the client PC, this is the access point. As it is little far, so pump in more power. With this, you are saving up to 72% of the RF in terms of watts. Almost saved around 1 watt, because access point consumes less power and you need less watts. Yeah, then something called ROHS compliance. So when we buy a product, then what we do is, we are the manufacturer, we buy a product and we ensure that the product, we need to buy all the components. The components, whatever we procure, we should follow the standards, so that we are unnecessarily not radiating the hazardous components. Also, we take care of the packing for recycling. We use a recycling packing material. If we want to talk about SmartLink as a company, what we do? SmartLink, we are the pioneers in bringing IT networking in India. And we have over 2 decades of experience in manufacturing, sales and marketing in the IT industry. Company known for honesty, ethics, integrity, and respected by all its peers in the industry. We have strong pan-India network, excellent service support. We are first company to start local manufacturing of IT networking products in India. This is our office. We have office in Bombay and Goa. We have plant in Goa. Then our vision is to be a leading player in digitally connected world by offering a complete true value proposition from product design to customer delight. In 1993, we started our first SMT line at Goa under Smartlink Network Private Limited. The name changed to D-Link India Private Limited after entering a joint venture with D-Link Corporations. In 1998, initiated a SCS product, structured cabling solutions, developed and manufactured SCS products locally, a plant in Goa, which became a number 2 brand in the country. And we have a second manufacturing facility with high-speed SMT line built in Goa. 2001 we went public, so from private company we became a public listed company, listed on both NSE and BSE. We started adding a lot of manufacturing plant. We launched a CS range of products under brand name Digilink. We also launched DigiCare to take care of our service and support. In 2009 we demerged and became a SmartLink Network Systems Limited and focusing on the active range of products called Digisol. Digisol, we have a range of active networking products in converged communications. We also launched Digilite for our motherboard solutions, for motherboard requirements. Then transfer of Digilink brand to Schneider Electric under business transfer agreement. Started with my chairman, Mr. K.R. Nayak. Then we have CEO Bimal Raj. Then Mr. Jangu Dalal, he was industry veteran. He was with Cisco president, and he is acting as a non-executive director. And we have so many stalwarts as a board of directors. Then we have 4 state-of-the-art plants, self-contract. Then we have a sales, market, distributions, Digisol for converged communications. We have a DigiCare integrated support and service. We have got 64 RMA centers across Pan India for the services part. The SmartLink has been instrumental in driving the force-paid successful launch and growth of many MNC brands in India. Today we are building our own truly Indian MNC brands. We have 3 brands, Digisol, Digilite and DigiCare, driving the SmartLink business. Digisol for ranges from wireless, broadband routing, switching, IP surveillance and VoIP solutions. And we have 17 offices, branch offices, 64 RMA centers. We got a lot of awards and recognitions. This is the product which we talk about. We talk about chassis solutions. We have managed switching solutions, web managed switching solutions. We have entire range when we talk from the switching point of view, switching solutions. Then we do have a VMS solutions, video management solutions for IP surveillance, VoIP solutions, LAN extenders and USB printers. Under the switching, we have managed solutions. We talk about green power saving. All our managed switches have the green power savings. All switches comply with IPv6. We have varies from 8 port and 2 uplinks to all the way to 48 port with 4 uplinks. And we also have one product which talks about 1/100, the 48 port switch. You can put a 1 gig uplink for the backbone. Tomorrow you want 10 gig backbone. Just remove the SFP port and install SFP plus ports. The 1 gig becomes 10 gig backbone without doing any configuration changes at the switch end. Then we have Ashtaka series. We have Stallion switches, which is fully redundant. We have a redundant management module, redundant switching fabric, redundant power supplies. We have it supports MPLS, IPv6 as well as fully redundant chassis. We talk as Stallion chassis. So I want to conclude my last slide. We are experienced but young. We are seasoned player with fresh ideas. We have a youthful team with knowledgeable leaders. We are at SmartLink Network Systems Limited. Thank you. Questions, right?
I can take 2 questions.
Don't worry, we will take your brand to the global market. So we have on a business agreement, we offered our cabling solutions to Schneider. So with the help of Schneider, I think it is selling in European market as well as in US market, plus in Indian market. Schneider has got a huge product range. Also goes along with the bundle as a solution. Yes, sir. Any other question?
What is ROHS stands for? Section of authority is subscription.
Yes, sir. Yes, sir.
There are 2 tables school of thought actually. One you told about the fan motor power, shutting down the fan motor and going down.
Fanless design, yeah.
But there is a school of thought that whenever you shut down something and start it up, the power consumed is very high.
Correct.
And there is a school of thought it is better to keep it idle for some time.
Okay. Actually, this is again debatable. This comes, let's say we have holidays on Saturdays, Sundays. Okay. Normally during if it varies from different places to places. Let's say if you take Bangalore, normally it's a cool place. It used to be an air conditioned city once upon a time. Okay, you don't need a fan. Now we can't live without a fan at this point in time. Some of the switches, what we have done is on web managed switches, we have designed some switches without fan. okay, without fan. Okay, we know that, and we've taken care of the air ventilation properly, front to back ratio, back to front ratio, all those things. Some cases, it's a managed switches where we thought fans should not be continuously on. Let's say since we already is a green product solution, green Ethernet embedded into it, and the heat generated by the ports is less compared to normal switches. So whenever the heat goes up, then only you switch on the fan. Once it comes to some, it's a design aspect. When it comes to certain temperature area, you shut down. Power on it more, right? Okay. Probably maybe I can give it to my PM team. Probably they thought this is not in all the products. In some products, maybe I'll take your point. I'll inform them accordingly. Idea is to reduce as much as possible. That's the problem. That's the bottom line.
Thank you very much.
Thanks, ma'am.